Lesson 1-2, Properties of Real Numbers. In this lesson, we will talk about classifying real numbers and evaluating expressions. To start with, again, we're going to do vocabulary. So these are going to be different number groups. So as we continue throughout the year, we are going to be using these names in directions, in domain and range, so lots of things. So it's very important that when one of these vocabulary words is said, you know what type of numbers that we're talking about. So when you're looking at this, the name of the group of numbers is underlined in blue here, and then we have its definition. And then in math, we actually have a symbol for it so that we don't have to write out the whole set of words each time. So real numbers we're going to see as kind of this bolded R. So in real numbers consists of all kinds of numbers. So basically every number that you know up in this point in your math career is a real number. So positives, negatives, whole numbers, zeros, decimals that end, decimals that don't end. Pi is a real number. Okay. So if we're trying to think of it in terms of a chart, so that's usually the easiest, real numbers are basically everything. Okay, so real numbers are all the numbers that we know right now. And then under that, we have two separate categories. So it's either going to be considered a rational number, where it's a fraction or a decimal that ends or repeats, or it's going to be an irrational number. So that's a number that's a decimal that doesn't repeat or end. So again, if I move this down a little bit, so it's going to be either rational, which we're going to denote with a Q, so this is a bolded Q when we write it, and then irrationals is a bolded uppercase I. So it's very important that the cases are the same when we're talking about this, or if you're reading them in your book. Okay. So some examples of our rationals, again, are going to be fractions, or decimals that repeat, or decimals that end. And then our irrationals are going to be decimals that don't end. And those are going to come from radicals that can't be simplified. So the square roots of stuff. Or we could do the cubed root or the fourth root. So things that aren't going to end. Now, irrationals doesn't have any more subcategories. But we do have more underneath rationals. So our next group is going to be the integers. And that is denoted with a bolded Z. Okay. So integers are both positive and negative whole numbers. So 1, 2, 3, -1, -2, -3. And then we're also going to include 0. Okay. So again, we have underneath rationals, we have integers with a Z. And then these are our sets. So it's all the whole numbers, so including 0. So positives and negatives. Okay. So these little dots mean that this continues. So I can have 1,000 in here, and that's going to be an integer. Or -1 million would be an integer. And then underneath an integer, we have whole numbers. So that's going to be a bolded W. And those are going to be only the positives and 0. So now we're getting rid of all of our negatives in our whole numbers. So it's all the positive whole numbers, including 0. And then we have one more set called the natural numbers. And that's going to be denoted with an N. And these are just positive whole numbers. So these are our counting numbers. So we don't include 0 in this set. So here's our little chart. So again, when we are classifying, everything is going to be a real number. And then it will either be rational or irrational. And then our rational has these subcategories. So now when we're looking at this chart, if I'm in the natural numbers, so like 4, for example, 4 goes into all of these categories. So 4 is a natural number, that's its smallest set. It's also a whole number, it's also an integer, it's also a rational number, and it's also a real number. So now if I go to whole, so let's say I have 0. So 0 is a whole number, it's also an integer, it's also rational, and it's real. But it is not a natural number, okay, because it doesn't meet this definition. Same thing with our fraction. So our rational number is going to also be considered real, but it can't be any of these things, so it doesn't fit the definition. All right, so let's do some examples of classifying. So here our directions tell us to name the set of numbers to which each number belongs. And we're going to name all the sets. So not just the smallest, we want all of them. So now I like to start with the biggest one and then go to the smallest. So since we are dealing with a negative 23, that is going to be a real number. And since there is no decimal, it has to be rational. And then our next one is an integer, so it's a negative whole number, so that's an integer. And then whole numbers, so since it's negative, our whole number definition, if you remember, is the positives. Okay, so it doesn't fit into this category. So negative 23 is going to be real, it is rational, and it is an integer. All right, so if we look at our next one, so square root of 50, well, 50 is not a perfect square. So that means if we actually do this out in our calculator, we're going to get this really long decimal that never ends or repeats. So we know that it has to be real. And then because of the decimal that won't stop or repeat, that means that this is irrational. And if something is irrational, we don't have to worry about any other subcategories. I do want to warn you to be a little bit careful with radicals. Let's say we ended up with the square root of 25, if that was given to you. Well, I would need to simplify this to a 5 before I started categorizing it. And then since it's a 5, it would be real, rational, and then it's also going to be an integer, because it's a positive whole number. And since it's a positive whole number, that also makes it a whole number and a natural number. Okay? So make sure if you can simplify a number, or a fraction really, or a radical, that you simplify first and then classify. All right, so if we take a look at our next one then, so again, we can't simplify, so we know that this is real. And since it's a fraction, that makes it rational. But we can't write it as a whole number. So since we can't write it as a whole number, it's not going to be part of any of our subcategories. So we're done. All right, last one that we're going to do, so 0. So real, rational, and then it's going to be an integer and a whole number. And it can't be a natural number because remember, natural numbers are only the positive whole numbers, and 0 is not considered to be positive or negative. It's just 0.